Welcome to Math Maxtra. This is Saritha. Today our topic is similarity. What is similarity? So when we say the given two figures are similar to each other. See, when we say when the two figures are similar, in the previous class we have seen what do you mean by congruency. In the congruency, the two figures must follow two conditions. What are those? The two sizes must be equal and two shapes must be equal. So, but when you come to similarity, what is the conditions it should satisfy? Only one condition, that is those two figures must have same shape. So we don't care about the size of the figures. We just see whether the given figures have same shape or not. So that is what a similarity is. See, you take any two figures. So first of all, I am taking two line segments. This is one line segment. This is another line segment. Now tell me whether these two line segments are similar to each other or not. See, so our only condition is must have same shape. So always the line segments have same shape. Yes, both have length. So same shape. That is why we say all the line segments are always similar. See, we don't care about the length of the line segment. So the only one condition it should satisfy is both should have same shape. Yes. How can we represent a similarity? So we represent similarity with the symbol like this. So this is the symbol we use for similarity. So this is a line segment AB. This is a line segment PQ. So how we write? AB line segment is similar to PQ line segment, isn't it? Next, any two circles, one circle is okay like this and other circle is so this is one circle and with center A with radius R1 and this is another circle B with center B with radius R2. Now this is a C1 circle, this is a C2 circle. So now tell me, are these two circles similar to each other? Yes, all the circles have same shape. They may have different radius, but both have same shape. That is why we can say all the circles are similar to each other. All the circles are, if you take any two circles, they are always similar. So how can we represent a circle? So this is the circle name and in the bracket you have to write the center first. This is a center A with radius R1 which is similar to this circle. So this circle name is C2 and with center B with radius R2. So this is how we represent a circle. So these two circles are always similar. Whatever may be the radius, you don't consider. You just see whether they have same shape or not. Okay. Now tell me, what about two right angles? You take two right angles. This is one right angle and this is another right angle. Now tell me, are they similar to each other? Yes, we have seen in the last class, that is all the right angles are always congruent, means they will satisfy both the conditions. They have same shape and they have same size. That is why we said they are congruent to each other. So here only one case, one condition is enough to satisfy. So that is already satisfied because all the right angles have same shape. That is why both the right angles are always similar. You take any two right angles, they are always similar. Okay. So next one is take an equilateral triangle. So take the case of equilateral triangle. See, this is an equilateral triangle. And this is another equilateral triangle. PQR. Yes, this is 60 degrees. This is 60 degrees. This is 60 degrees. But it has length 3 centimeters, 3 centimeters, 3 centimeters side. And this is 6 centimeters, 6 centimeters, 6 centimeters of side. Now tell me whether these two equilateral triangles are similar or not. See, both are equilateral triangles. Always, all the equilateral triangles look alike. Means they have same shape in which all the sides are equal. So we don't consider the length of the side. We just see whether the both have same shape or not. That is why all equilateral triangles are always similar. Yes, all the equilateral triangles are always similar. Next case is squares. You take any two squares. So this is one square and this is another square. So in this case also what you need to see? You need to see only shape of the figures. So all the squares have same shape, right? That is why they are similar. All the squares. You take any two squares, they are always similar. See, okay, these are fine because these are all regular. What is a regular polygon is? See, you have to check the similarity in case of polygons first. So what do you mean by a polygon? A simple closed plane figure which is formed by the line segments in which all the sides are equal. Means you have considered one equilateral triangle. What happened in the equilateral triangle? All the sides are equal. Okay, this is one equilateral triangle. And in this next case we have considered a square. So square is also a closed plane figure which is formed by the line segments P, Q, R, S. All the sides are equal. Okay, so means this is also formed by a line segments and it has all the equal lengths, equal sides, and this is also a simple closed plane figure and it is also formed by the line segments in which all the sides are equal. So you increase number of sides. So you increase number of sides. So now I am considering a pentagon in which 5 sides are there. All the sides are equal. Okay. A, B, C, D, E. Pentagon. So in this also all the sides are equal. See, these we call them as a regular polygon. Means all the sides in the figure must be equal. Yes. Now this is also a polygon. It has 3 sides. This is also a polygon. Yes, this is also a polygon. So, but this is an equilateral polygon. Yes, equilateral triangle is also one of the polygon. Okay, this is a regular triangle is equilateral triangle. Regular quadrilateral is square, and a regular pentagon. Okay, so these are the regular polygons. Now tell me whether any two polygons you consider, whether they are similar to each other or not. See, I'm considering one polygon as a square and one polygon as a pentagon. Now tell me whether these two figures are similar to each other. No, right? Because see, this has 4 sides. This has 5 sides. Even the number of sides are also equal. They may look alike or not. So they are different. They are completely different. This shape is different. This shape is different. These two figures don't have same shape. That is why we can say any two regular polygons need not be similar. See, this is also a regular polygon. This is also a regular polygon. We are considering any two regular polygons, but they don't have same shape. That is why we are saying they are need not be congruent. Means if we take two squares, then you can say they are similar. If you take one square, one pentagon, we are saying they are not similar. That is why if you consider any two regular polygons, they need not be similar. Yes. So what about any two polygons? Not regular polygons. You consider any two polygons. The polygons may be regular or irregular. So whatever they may be. So what happens if you consider any two polygons? So in the case of regular also similarity is not working. Then how can we say in between the two polygons similarity works? So similarity doesn't work in between any two polygons. Okay. So if the statement is given like this, means any two regular polygons with same number of sides, then that time, see, okay, pentagon, it has five sides. You consider one more pentagon which is regular, and but the length of the side may be different for these two polygons. But what happens, the polygon, this pentagon and other pentagon looks alike because the number of sides are equal. So that case they are congruent. So you need to carefully observe in the question whether they are given any two polygons or any two regular polygons or any two regular polygons with number of sides equal. So you have to observe the difference, then answer the question. Okay. So these type of statements are very important while solving the questions. Okay. Next. So we have seen polygons, regular polygons. So when we say two polygons are similar to each other, so we have two conditions in order to satisfy similarity between the two polygons. What are those? So the first one is corresponding angles are equal. And the second one is corresponding sides are in proportional. So proportional. Yes. So if these two conditions, if you take any two polygons, if these two conditions are satisfied, then we can say those two polygons are similar. Now check. Okay. So I am considering one rectangle. Okay. So it has length 6, width 2. Okay. A, B, C, D rectangle. This is. And I am considering one more rectangle which is also a polygon in which see P, Q, R, S. Now this width is 4 and this length is 12 centimeters. Okay. So this is ABCD rectangle. This is PQRS rectangle. Now tell me whether these two rectangles are similar or not. See what it has to satisfy. It has to satisfy these two conditions because these two conditions applicable for any polygons. So I am considering rectangle. This is also a polygon. So corresponding angles are equal. You check in the rectangle all the angles are equal, which are equal to each equal to 90 degrees. Yes, 90, 90. And in this also it is also a rectangle, so I am considering each angle as a 90. So this angle, this P angle is corresponding angle to angle A. So this is equal to 90 degrees. This is also equal to 90 degrees. Similarly, this angle Q is corresponding angle to angle B. So this is 90 degrees. This is also 90 degrees. Similarly, all the corresponding angles are equal, isn't it? Yes, first condition is satisfied. Now move to the second condition. corresponding sides are in proportional. What do you mean by proportionality? See, you take one photo frame. So it is in the ratio of, see, with length 6, width 2. So if you want to increase the size of the photo frame, if you increase only length of the photo frame, will both the photo frames look alike? No, right? So if you increase the width 2 times, suppose I am increasing the width, so 2 times, so 2 to the 4, so okay. The next case, width length is I am taking 6 centimeters. So in the similarly in the other rectangle, if we also increase 2 times, then these both figure represents similarity. Yes, both figures look alike. So similarly, if we increase width by 2 times and length by 4 times, will they look alike? They don't look alike, because see, we need to, if any two figures need to be look alike, they should follow a proportionality. Means always all the sides must be increased certain times, whether they are 2 times, 3 times, 4 times, like that. So means the ratio must be equal. So you increase any number of times, but the ratio must be equal. So now that is what a proportionality. See here, 2 centimeters of width. So I am increasing 2 times. So 2 2s are 4. Okay, 4 centimeters of width up to 4 I have increased. Okay. So next, 6 centimeters I am considering. So this is also 2 times 12 centimeters. So this length is increased 2 times, that is 12 centimeters. Now these two are similar to each other. Yes. This is a rectangle ABCD is similar to rectangle PQRS. Yes. That is the proportionality. Okay. Thank you.